Implicit differentiation. I'm going to cover this pretty fast. Got three, or as fast as I can. Got three different equations or functions. Three different implicit functions here. So what is an implicit function? Well, an explicit function would be like y equals, and then this, some kind of x squared or x squared plus 2x, some kind of function, right? An implicit function, and as we can kind of see looking at these that I have, it's not so straightforward. It's not explicitly just y equals this. There's stuff is being applied to y and x. So kind of seeing what that looks like, and we can see we have ours, but what's a basic example is right here. So you have y equals x to the 2/3 power. That's how it would look explicitly, but implicitly it might look like y cubed equals x squared. So why do we have implicit differentiation? And almost always, because many times if it's already in implicit form, it's very difficult to just kind of switch it over to explicit form, or else we wouldn't have to really worry about this so much. So we just came up with, we noticed there's an easier way to get the derivative, or the route to just getting the derivative implicitly, in most cases, is just easier than trying to get the function in explicit form. So this right here is just a layout of the procedural format. Just look over it. I'm going to go over it in kind of my own little style. I'm not going to follow these super strict, but I figured it'd be nice to have these little slides in here. But basically, number one, you're just going to differentiate the same way you normally would. Number two, you collect the terms of dy dx with derivative of y with respect to x on one side and the terms on the other side. And you might think, well, how are you getting that? I don't see that anywhere. We'll go over that, don't worry. Anything that has the top variable, the y, anything that you take the derivative of y with, think of like, you know how the chain rule, when you do the outside function and you have to multiply it to the inner function? Well, in this case, when you take the derivative of the variable that matches the variable in the numerator, so dy over dx, so whenever you take the derivative of y, then you rewrite whatever that the derivative ends up being, you multiply dy dx onto the end of it. Like I said, we'll go over it later. Don't sweat it too much. I don't want this video to be too long. I can ramble. So, all right. So jumping right into it, let's go ahead and tackle this one. We have 2x cubed equals 2y squared plus 5. And do know that these are, I'm running into them for the first time. I just pulled these off of the web. I do have answers that I'll pull up after I do each one, make sure we're right. But I don't know. I didn't do these before. I'm just jumping into it. So without further ado, here we go. So what we have is 2x cubed equals 2y squared plus 5. All right. What we're going to do here is dy dx of the entire thing. And remember, we're just going to differentiate like we normally would, just keeping an eye out for the matching variable, this y right here. And we can see it right there, so we know we're going to have a dy dx that we're going to have to add in. So just continuing on, dy dx, derivative of 2x cubed, and I'm only going to write it out like slow like this, dy dx for each one on like the first line. After this, we're gonna do it in our heads. I'm just doing it here so everyone knows the notation. So dy dx of 2y squared plus dy dx of 5. Okay, so The derivative of 2x cubed is 6x squared equals the derivative of 2y squared is 4y, and we're going to multiply that dy dx right there. So continuing on, and just it's a constant, so 0, given normal differentiation rules here. What we're going to do from here is, and I think it said this in the procedural format, where you isolate dy dx, and you have solved for dy dx. So in this case, very simple, divide 4y both sides. And that's going to give us, we go ahead and switch it around, pull this dy over here, and just say dy dx equals 6x squared over 4y. And let's I'll pull up the answer real quick, skip, and see if it's, I did get it correct, but I did not simplify. So remember, simplify. Now moving on to 3x squared. Remember, I didn't do these, so hopefully I'm not wrong here. I'm pretty confident in myself. I'll edit in any corrections that I need to make. So 3x squared plus 3y squared equals 2. So same deal here, just put it, we're going to put it all in dy dx, and derivative of 3x squared is 6x, derivative of 3y squared is 6y. Don't forget to tack on the times dy dx equals derivative of that is 0. And you'll see what we have here is a 0. We're just gonna get the, remember, we're just gonna isolate the dy dx, and we're gonna have to kind of go around about here, just subtract the 6x from both sides, and then equals negative 6x, divide 6y by both sides. And that's going to give us, remember, let's remember to simplify here. So we'll just have dy dx equals negative x over y. Our answer, dy dx equals negative x over y. Same answer from the worksheet. So all good on that one. Last little one we're going to try here. So 5x cubed plus xy squared equals 5x cubed y cubed. It looks ugly and looks messy. It looks like they're going to want us, they very well, yeah, looks like we're going to have to use the product rule. So product rule, same deal as with normal differentiation. Just remember to add the dy dx when you need to. So dy dx, all this, derivative of 5x cubed is 15x squared plus xy squared. So we're just going to apply the normal product rule here. I'll do this, the xy squared, off to the side, and then for the rest we'll do it in our head. But basically we just have the derivative of x times y plus x times the derivative of y. I forgot that y up there. Times the derivative of y squared. Sorry, there's a y squared right here as well. And what we get right there, derivative of x is 1, so we'll just have y squared plus the derivative of y squared is 2y, so we'll have plus x 2 oh sorry, let me rewrite that better, plus 2xy, and don't forget to multiply dy dx. And you might be saying, where'd you get the x right there? Well, don't forget right here. So we took the derivative of x and we got 1, and 1 times y squared, that just came down here, and we got y squared. The derivative, or I'm sorry, on this side of the plus sign we had that x, and so we just dropped the x down immediately. We're gonna have that, and then that's where we pull out the that's where we do the derivative of y squared, and which ends up being 2y. And so since it's all multiplication, we can rearrange it just like 2xy, and then we just tack the dy dx on the end. And so we're going to take all this right here, and we're going to throw it in over here. So this ends up being 15x squared plus y squared plus 2xy times dy over dx. Now let's go ahead and do the 5x cubed. Let's got a little beep there. 5x cubed I'm sorry, 5x cubed y cubed. And so what we have right there is dy dx 5x cubed times y cubed plus 5x cubed times dy dx y cubed. And so the derivative of 5x cubed is 15x squared, sorry, times y cubed plus the 5x cubed can just come down times the derivative of y cubed. We're going to have 3y squared, so 3y squared, and don't forget to tack on the dy dx on the end of that. And we can go ahead and fill this in right here. In fact, I'll just move it over, kind of scoot it over right there. And this is what we have now. I mean, we broke it out, and it took a minute, but we broke it out. So now from here, we can do algebra and consolidate. Let's just isolate some variables. So let's try subtracting 15x squared from both sides, 15x squared. And that will also be its own variable over here. We can subtract y at the same time, y squared, and we won't subtract 2x. Why? Because it's connected to the dy dx. Let's just leave that alone for right now. It's scaring me. So, but the good thing for you guys is you're getting a raw cut video. I mean, I have to struggle through this. You should feel my struggle here. So, subtract the 15x squared from both sides and the y squared from both sides. I should start using different colors. Let me get rid of that line in the middle. Alright, so, because it wasn't a fraction. So, from here we're going to have 2xy times dy dx equals 15x squared y cubed plus, let me tack that y cubed. I'll tack the other dy dx on the end to keep things clean. So minus 15x squared minus y squared plus 5x cubed 3y squared times dy dx. Now that looks somewhat better. From here we can subtract this 5x cubed 3y squared times dy dx from both sides of the equation. All right. Looks good, looks good. And what we will get here is 2xy times dy dx minus 5x cubed 3y squared times dy dx equals 15 squared y cubed minus 15x squared minus y squared. And from here, now we have two like terms right here, because the dy dx in both of these, and they're separated by this minus sign, and they're grouped together on this equation. So we finally got it where we want it. Jeez, old Pete's, math can be just tedious. So now we factor that out, and then we have a dy and things that we can really see the light at the end of the tunnel here. Dy dx times 2xy minus 5x cubed 3y squared equals forgive me, I picked up a negative somewhere. I did not mean to pick up this negative. No, I don't want that negative. Sorry if you seen that and wrote it down. We don't want that. So 15x squared y cubed minus 15x squared minus y squared. And let's just do the final thing we need to do here. Divide 2xy minus 5x cubed 3y squared from both sides. 2xy minus 5x cubed 3y squared. And I'm not going to write that again. I'm just going to make this look pretty. Pen and paper might be a different story. Technology is amazing. Cool. So let's check if that, yeah, and we got it. So I mean, as you can see, some of these will take a minute. It'll take a while to do, but you're just getting normal derivatives. So the concept here, the main point, it's normal derivatives. But when you run into that matching variable, that's in the numerator d this with respect to d this, so the dy over dx, the derivative of y with respect to x, whenever you run into that variable, make sure to tack on that dy dx. And then when you get down to the end, after you get that derivative, then you just solve for dy. So you get the derivative and then solve for dy dx. Pretty not so crazy stuff to conceptualize. That's it.